Good day to everyone. So in the last video we have seen about the intrinsic functions which we have used in the arrays. We have seen the three types of intrinsic functions: elementary intrinsic functions, inquiry intrinsic functions, and the transformational intrinsic functions, which are used in the arrays, which are the intrinsic functions which we have used in the arrays. We have seen some examples also. So the arrays that we have worked with so far in this up to this is the one-dimensional arrays, or which is also called as a rank 1 arrays. So these arrays can be visualized as a series of values which is actually laid out in the column with a single subscript used to select the individual array elements. For example, you can see this figure where we have seen the elements are arranged in a row wise. Such arrays are useful to describe the data that is a function of a one independent variable, such as a series of temperature measurements made at fixed intervals of time. For example, if you fix time and you are measuring the temperature, which is actually depending upon the single variable, so you can write it as a one-dimensional array. But some types of data that are functions of more than one independent variable, for example, if you might to wish to measure the temperature at 5 different intervals or 5 different locations or to 4 different intervals of times, then in case of that kind of situations, we require the much more information about than the one-dimensional array. So we require the two-dimensional array. For example, if you take the 5 different temperatures and temperature of the different locations or for 4 different times, then you require the 20 measurements could be logically be grouped with 5 different columns and 4 different measurements, each of with a separate column for each location. For example, you can see here where we have 4 rows and 5 columns. So we have to arrange the data in order to get the much clarified information. So if you want to design this kind of arrays, then the Fortran has a mechanism especially designed to hold this sort of data, that is called the two-dimensional array. So the two-dimensional arrays are arrays whose elements are addressed with 2 different subscripts, and any particular element in that array is selected by simultaneously choosing the values for both the subscripts. For example, if you look into this corresponding figure, you can see that this is a 1, 1, and this is the row 1 and column 1, and this is row 1, I mean the row column 1 and the row 2 are 1, 3, 1, 4. Similarly, this is actually 2, 1, 2, 2, 2, 3, 2, 4. So if you want to, similarly you can write the other elements. So if you want to specify the particular column, a particular number from this array, then you have to mention both the row number as well as the column number, so that you can easily mention the corresponding number. So in this video we are going to see how to declare this kind of two-dimensional arrays and initialization of two-dimensional arrays in the Fortran program. So the type and size of the two-dimensional array must be declared in the computer using a type declaration statement, and you can see the example here. You can see as usual, like the one-dimensional arrays, you have to mention what is the type of the array and the dimension. In this dimension, you are now instead of using the one scalar variable, you have to mention 2 different sizes. The first number is actually mentioning the row, and the second number is actually mentioning the column. So the sum, the variable sum, the array sum, which is having a 3 rows and 6 columns. So similarly, you can see the other example where the variable a, the array a, is actually declared with the dimension integer type, with the dimension of the first dimension having the 101 elements, and the second dimension having a 21 elements. So similarly, you can also mention the character variables also with the length of 6 or the corresponding dimension, everything you can give it. So if you look into the first example, So this type of statement declares a real array consisting of 3 rows and 6 columns for a total of 18 elements. So the legal values of the first script is 1 to 3, and the values of the second column is script is actually running from 1 to 6. So any subscript values out of the above this bound is actually called as out of bound arrays, which already we have seen in the one dimensional array. Similarly, the second is also having a the 101 rows and 21 columns. So the multiplication, the total shape of the array will be the 101 into 21, which is around almost equal to 2021 to 121 elements are already available in the array A. So the third example consisting of the character variable with the array count, which is actually declares the array consisting of 7 rows. That means the -3 to +3 is having 7, and it is having a 10 columns. So totally it's actually having 70 elements in the array. So the type is this array type is a character variable type, and it is having each array having a capacity of holding 6 characters. So this is also legal to include the character array also. So how this numbers or the values which you are going to give in the two-dimensional array is going to be stored in the computer memory is one of the important information we require to know. So we have already learned that the rank 1 arrays of length of n occupies the n successive locations of the computer's memory, which we have seen here in this figure. So A 1, 1, 2, 1, 3, 1, everything in this series order. So similarly, the rank 2 array also having the size of m into n. So we can just take in the, for clarification, we can say this is a R and this is C. That means m is R stands for row and C stands for column. So we have a R into C successive locations in computer's memory, which is occupied by the two-dimensional array. So the how the elements of the array arranged in the computer's memory is what we have looking here. So Fortran always allocate the array elements in column major order. That is, Fortran allocates the first column in the memory, then the second, and then the third column until all columns have been allocated. For example, if you see this figure, so the memory allocates the 3 into 2 size array. So as we can see from this figure, the array elements of A 2, 2 is really a fifth location reserved for the corresponding memory. So that is what we have seen. The order of the memory allocation will become important when we discuss data initialization and the input and output character statements, which we are going to see in the forthcoming classes. So next thing we are going to see is the initialization of the two-dimensional arrays. So as like the one-dimensional array, two-dimensional array also initialized with the three different types. As like the one-dimensional array, like assignment, you can initialize the two-dimensional array with the assignment statements as well as the type declaration, and also with the read statement. So which we have already seen for the one-dimensional array also. So the method, everything is actually similar, but only thing is you have to increase the one more dimension for the corresponding second dimension, and so that if you want to increment the second dimension, you have to use the another do loop or a increment loop. So the initial values may be assigned to an array to an element by element basis using the assignment statement with the nested do loops, or you can also mention the values of the array with using the array constructor. For example, in this example, I have taken the array which is having the name of istat, which is having the 4 rows and 3 columns. So the first do loop will take care of the initialization of the row, and the second do loop is actually assigning the column. So as I already told you that it is actually the two-dimensional array is actually working with the column major order. First the column will be filled, and then once the column is reached the maximum limit, then the increment in the row will be taken care of. So that first you have to the inner do loop will actually always initialize the column, and then the outermost do loop will initialize the row. So the equivalent array figure which is shown here is actually the equivalent to the corresponding code we have defined here, which is having a 4 into 3 matrix with the name of istat. So you can see that the first column is actually filled first, and then the second column and third column. Once the column is finished, then it assigns the second second column to the next variable, next value. So this is how this two-dimensional array look like. But in computer memory, the notational arrangement of the computer memory is shown here, where you can see that it is actually showing with the one-dimensional array in the computer memory, but the address which we have, the elemental address which we are giving, is actually stored as a 1, 1, 2, 1, 3, 1, etc. So this loop, the statement will actually assign the initialize the values to the corresponding array element by element method, but also you can do it with the you can give the whole array initialization using the array construct. So which you can also do it here, like you can just initialize the array initialize the array with the same dimension, and you can also give the corresponding values in the open and close parenthesis and with the backslash in between the this open and close parenthesis with the slashes. You can give the values, whatever the values you can give, like previously we have discussed in the one-dimensional array with the using control construct, array construct. You can also initialize the two-dimensional array. But here the problem is this is, suppose if you are declaring the two-dimensional array like this array will this array construct will not work. So what happen is the array construct produces the 1 into 12 array. However, but we need the 4 into 3 array. But once if you are declaring the initializing the array with this kind of statement, then it will actually produce the 1 into 12 sized array. So also they both have same number of elements. The two arrays are not comfortable with they don't have the shape of the array 1 by 12 and 4 into 3 is entirely different, because they have a different shapes, and that cannot be used as the same operation. So this assignment statement will produce a compiler time error in the Fortran 90 or 90 suppose if you are using the Fortran 90 compiler. So suppose if you want to initialize the array values with using the array construct, then you have to always suppose if you are using array construct in the two-dimensional array, which always produce the one-dimensional arrays. So suppose if you want to overcome this kind of situation, then we have to use the another intrinsic function, that is the transformational intrinsic function, which is called the reshape. So once if you are using the reshape with this particular syntax, that means the corresponding variable which is equal to reshape into the array 1 and array 2, then the array 1 contains the data to reshape the array 2 in a rank 1 array, describing the new shape. So the number of elements in array 2 is the number of dimensions in the output array, and the value of each element in array 2 is the extent of each dimension. So the number of elements in array 1 must be the same as the number of elements in the array 2, so specified in the array 2. So once if you are using the reshape then, so for example, once if you are using the reshape, then the corresponding array will be alternate from one. They transform the 1:12 array into the 4:3 the 4 into 3 array. That is the array value which is equal to the reshape. This is the actual array 1. That is the value of the array 1, and this is array 2. So based on this array 2, the numbers, that means the values initialized in the array 1 will be reshaped from 1 into 12 into 4 into 3. So the only thing which we have to be careful about the reshape function is, suppose if you are using the reshape function, intrinsic function, then it maps the elements from a old shape to the new shape in a column major order. Thus the first element in the array constructor becomes whatever the istat, for example istat of 1, 1, The second element will be the 2 comma 1, not 1 comma 2, but it is actually taking the I stat of 2 comma 1 and as well as the 3 comma 1. And similarly, next in the next element will be the 2 comma 2, sorry 2 comma 1, sorry 1 comma 2, sorry 1 comma 2, 2 comma 2 and 3 comma 2 and so on. So the only thing which we have to careful about the using the reshape is the reshape will always convert to map the old array to the new array with the column major order. Okay. So you can also declare the two-dimensional array using the declaration statement. That means the type declaration statement, wherever you are using the you are initializing the array value. So the initial value may also be when the type declaration statement is used to initialize the rank 2 array, the data values are loaded into the array in the order in which memory is notationally allocated by the Fortran compiler. So since the arrays are allocated in column major order, the values listed in the type declaration statement must be in a column order and not with the row order. So all the elements in the column 1 must be listed in the first statement, first, and then followed by the elements in the column 2 and then column 3 and so on. So suppose if you are looking at the same array with the name istat contains the 4 rows and the 3 columns. So therefore to initialize this kind of array with the type declaration statement, the 4 values of the column 1 must be listed first and then the 4 values of the second column, and then finally you have to mention the 4 values of the third column. So the values used to initialize the array must have the same shape as the array, so that we have to use you can also use the reshape function where we have used in the previous example with the initialized. Therefore, the array which is the istat could be initialized at compilation time with the statement of the integer and the dimension of the array you can mention as a 4:3, and array name with the which is equal to this, and this actually the continuous function. So you can is actually mentioning that it is the same line with the reshape and the array 1 and the corresponding the dimension. How we are actually reshaping this array into this values into the two-dimensional array. You can give it the 4:3. Okay, so this is how you have to declare the initialize the two-dimensional array using the type declaration statement. So the final one of the array declaration is the using the read statement. So this is actually the read statement. Sorry, I had just properly not mentioned it. It's actually a through using the read statement as like the one-dimensional array. We have used the read statement to read the data from the data file, and you had the initialize the array with using the values in the data file. Similarly, the same like one-dimensional array, you can also use the same the syntax. Instead of mentioning the one dimension, you can mention the two-dimensional array with the corresponding name, and you can also open the file with the file name and what are the status and action and everything. You can mention it, and you can just read the data from the corresponding data file using the read statement. So one can also use the implied do loops to read the statements to change the order in which the array elements are initialized. For example, suppose if you are having the data file which is having the values of 1 1 1 1 2 2 2 2 3 3 3 3 and okay, so these are all the values which is already available in your data file. Suppose if you are reading the data file from the if you are reading the values from the data file, suppose if you are using the implied do loop, so you are using the two different do loops from the j is equal the values, so inner do loop actually loaded first and then the outer do loop, so that it actually then using this read statement, you can assign this values like this array. Suppose if you are using the read statement, suppose if you are using the implied do loop, then the first order, the column major order will be actually the two-dimensional array is actually following the column major order. So the implied the inside the column first be loaded first and then the row, so that the readed value will be in the terms of this. This is how this the value the array values will be stored in the corresponding memory of the computer memory. So the values would have been read from the corresponding data file in a different order than the previous example. So but suppose if you properly use the implied do loop to ensure the proper input values went into the proper array elements. So you can use it, you can do that with the corresponding respective the do loop, implied do loops which we are using. So I can explain the usage of how to use a two-dimensional array and how to do the operation using the two-dimensional array in a Fortran language. I can explain with one example. So the example shows that this is the below figure which is shown here is shows the series of electrical output power measurements at 6 different times for 4 generators. So we have to write a program to read the values from the disk file or calculating the average power supplied by each generator over the measured period, and also calculate the total power supplied to by all the generator at each time in the measured period. So we can see that the generator 1, generator 2, generator 3 and generator 4 producing the power with different times. So the generator 1 producing the power of the 20, 19.8, 20.1 and 20, 20 and 19 megawatts. So which is actually going in a single column, and the single column, and the generator 2 which is actually produced power will goes in the second column, similarly third one and the fourth one. So you can see that how these are numbers will be arranged is shown here. So in first time 1, the generator 1 is actually produced different the different powers which are actually shown with the different times in a column 1, and the column 2 shows the power generated by the generator 2, and the third column is showing the power generated by the generator 3, and the generator 4 generated power is actually shown in the fourth row. So what we have to do is we have to read this data files, this data from the data file. That means you have to keep this data in a data file, and you have to read the data from this data file in your Fortran program, and you have to calculate the average power supplied to each generator. So average power means you have to take the average of these times, and then you have to show the output as well as the total power generated by the each generator. You have to you have to take the average of this as well as this with the different times. You have to show the output. Okay, so this is the problem. You have to calculate, take this data, store it in the data file. You have to read this data from the corresponding data file in your program. Then you have to calculate the average power supplied as well as the total power supplied by all the generator at each time. Okay. So the corresponding program is shown here. So where I have I have taken 4 generated total number of generators as 4, and total time is taken as a 6. And so since you have to read the data from the file, so you have to mention the corresponding file name and the regular the declaration of the different variables and arrays. So here I can use the two-dimensional array to store the data from the file name, which is actually stored as named as a power. Then the array name is power, and average power and average sum of the average will be initialized with the 0. So first I ask the user to enter the name of the file which containing the corresponding data. So whatever the file is included, this file is actually opened in the compiler, and with the status. Suppose if the status is 0, then the file opening is successful. Otherwise, if they is showing the non-integer value, then the file opening the file is file is failed. So that if this is true, the status equal to 0, then it will do the corresponding other operations. Suppose if this is failed, then this the corresponding loop will be closed here with the status of file open failed with the status of corresponding status with the open file. Suppose this is true, then the sum of sum one, and you are actually reading the data file. You are reading the data from the file which is stored in the data the array called power. Okay, now I am going to taking the sum of the each and every power generated by the each generator. So I am going to take the time as the max time, and that means this I runs from 1 to 6, and the inner do loop actually having the number from 1 to 4. So whatever the power generated from this in do loop is actually taken for the sum, so that the two-dimensional array, that means the corresponding two-dimensional array with the what is the power the I time, that means the wherever the I time is incremented, then you will get the corresponding input the number from this input, then it is added with the previous array, and it is actually stored with the variable power sum of the power underscore sum with the initial increment of I time, that means the outer do loop. So once if the do loop is completed, then you can actually take the average of the each generator, and then here this do loop is actually taking the average of the total average of the each generator for the different times. So you can see here for the in this do loop, you are actually the outer do loop is actually measuring the time, and the innermost do loop is actually incrementing the generator number of the value of the generator, means the count of the generator. But here you can see that it is actually reversed. The outer do loop actually counting the generator number, and the innermost do loop is actually measuring the time, so that the row and column will be different for the different do loops. So once if you completed this do loop, you can actually calculate the average power. Here you are actually calculating the instantaneous power. So once if you completed these values, you have two different arrays with different values. That means the power underscore sum and as well power underscore average, the average power as well as the instantaneous power from the different generators. So you can easily calculate the instantaneous power, where you have already calculated from this. Here you can just print the value with the power. You can easily the corresponding time as well as the instantaneous power which we have calculated from this do loop, which is printed here. Similarly, the average power calculated in this do loop is actually printed in the next power. So where you are increasing the do loop from as function of time, here as a function of the total number of generators. So you can easily calculate the average as well as instantaneous power. So and then you can close the loop. So here you have what you have to look into is the important thing is how you are reading the data from the file name, and how you are actually manipulating the data. That means how you are actually changing the row as well as column in the two different do loops. Here actually you are in the first do loop, you are actually counting the generator number. That means this generator, first you are actually changing the generator number. That means you are taking the values of 20 and then 40, then 42 and 20, then adding all these things and taking the sum sum, and then you are actually taking it as for the first time. Okay, so that the first time, that means I is equal to 1, then generator value will be goes from 1 to 4, then it calculates the power and it is stored in the power sum of power underscore sum. Then after the do loop, the innermost do loop is increment, the innermost do loop is completed, then the outermost do loop will actually increment with the 1, the 1 by 1, so that it goes for the time 2. So that this time you are actually taking these values to take the average or sum or average. Okay. However, in this do loop actually working differently than this do loop, where first we are actually in the innermost do loop, you are actually changing the max time. That means every time you are actually calculating the average of this for first generator. That means the total power total power generated by the generator for each time. So you have to take the average of that, and it is stored in the power of I time into Igen, and then once if you completed this do loop, then the generator value will be increased, so that you are actually going for the generator 2 and you are counting the values of the corresponding values, then you are actually taking the average of that. Okay, so once you've done that, then you can just complete the print the result. So the printed result output is shown here. So actually in the data file, the data is actually shown in the column wise order. So the first value is 20.1, so 20, and then the second value is, that means in the column row wise, in the column wise, so the first value is 20.0 and second value is 19.8 and third value is 20.1, and the first row we have a 20 and again 20 and then 19.9. so you are actually filled the first each and every column. So once the column is maximized, then you are going for the second row. So every time you are actually filling the each and every column first, and then you are going for, once you are maximized with the column, then you are going with the another row. So that is how I have a data in my data file, and so the data file reader with the power, total power, which the instantaneous power which we have calculated is showing here. So it is actually readed the values of first it takes the 20.1 and then so for the instantaneous power, what is the loop is doing is, first it is reading the data 20 plus 40.3, then 42 plus 22.4, then it is taking the sum of this, the average of this, the sum of the values, and it is actually printed here. You can see that the instantaneous power is actually 122.7. that is actually the total which is calculated from this time. So similarly, you can actually calculate the instantaneous power at all the 6 times, and the second do loop is actually calculated the total power generated by each generator. So the generator 1 is actually totally having the 19.97 megawatt, the average power is 19.97 megawatts, and similarly the generator 2, 3, 4 is actually regulated. So while processing this output, the loop is actually presented, the loop is actually operated in this manner. So you're taking the average of all the 20.0, 19.8, 20.1, 20, 20 and 19.9, taking the average of this one, and it is showed as the total power generated, average power generated by the G1, which is actually shown here. Similarly for G1 as a G2, G3 and G4. Okay, I hope you understand how this two-dimensional array is processed in Fortran programming. So the main thing you have to mention, noted is the Fortran arrays will always work with the column major order. So suppose if you are reading the data from the file or initializing the values of the corresponding two-dimensional arrays, then you have to give the data accordingly. Okay. So probably I stop here, and we will discuss about this two-dimensional array in the class. And suppose if you have any doubts, then we can discuss this in the class. Okay. Thank you.